Okay, so this is what we want to do. I've done a bunch of this for you already. I would like you to go through this and sketch sine curve on intervals of 9. You know what? We can do it together. And that way we won't have this to do. So we can just finish this off. So let's take a look. It wants to define the following terms and state the corresponding values for y equals sine theta. Down here it wants us to sketch sine theta on intervals of 90 for the domain. So I need to go all the way from negative 360 to 360. All right, so a bunch of things here. Let's do this first, and then we'll fill up here. So 90. That'll be 90. That'll be 180. That'll be 270. That'll be, you know what? That's awfully small. I don't like that. That's a very small scale. I'm going to get rid of that. I think I'll do, that'll be 90. So every 2, 90, 180, so 270, 360. Yeah, okay, whatever. This will be negative 90, 2 over, negative 180, negative 270, negative 360. I'm going to, now if I was to make this 1, it'd be a pretty silly looking graph, like, right? It would, like, it just, if it went up to 1, it would only go up and down, and it would be a pretty sad looking graph. So let's make this 0.2, 0.4, 0.6, 0.8, 1. Let's make that 1. That's 0.2, 0.4, 0.6, 0.8. Let's make that negative 1. Okay, so let's graph. Now, I'm supposed to be doing sine curve on intervals of 90. Well, intervals of 90, I know, is the critical interval for the sine curve. So if I go out 90, I know that I'm going to go up to 1. And if I go out to 180, I know I'm going to come back down to 0. So the sine curve, I know, because I did the lesson with you just before, is going to look like that. Now, it's a different shape, kind of. It's certainly elongated than the other one because my scale is different. But I know that if I go another 180, I'm going to hit negative 1, and I'm going to hit back up to 0. And I know that my concavity needs to go like this. Okay, no triangles, no straight edges. These need to be nice and curvy. So there is one wavelength of the sine curve. Starts at 0, goes up to 1, comes down to 0, hits negative 1, and goes back up to 0. That is one complete wavelength for sine. Coming the other way, well, I can just follow the pattern. I'm going to come down to here, I'm going to come back to here, I'm going to go all the way up to here, and then I'm going to come back to here. Making sure that you get the concavity right, we can start to get the graph. So that's 2 complete wavelengths of sine. And it's going to keep going. So if I was to go 360, another 90, that would be 450, and another 90 would be 540, and another 90 would be 630. So what would happen is I would go back up to my maximum here because it's another 90 degrees, and then I would come back down to a 0 because it's another 90, and I would come back down to a minimum. So this would actually continue going this way. And the same would be true going this way. So this would be negative 450, negative 540, negative 630. And again, the curve would follow the same pattern. It would go down to a minimum, back to a 0, up to a maximum, and it's going to keep its concavity, and it's going to keep going. And la 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 la. So this is 2 wavelengths of sine curve, and this is the curve y equals sine theta. And what we've graphed is all of the points, theta comma sine theta, and in red we graphed it on this domain. So my domain went from negative 360 up to 360. That was what we call a restricted domain. Okay, and but it would keep going if I left the domain open. It would just be a periodic function and keep going and going and going. Okay, so let's label some things here. So for the curve y equals sine theta, what's the maximum value? Well, the maximum value for sine theta is going to be plus 1. Okay, that's the highest it can be. So the highest y value, or the highest range value, and it's going to be plus 1. The minimum is the lowest y value on the graph, and that's going to be negative 1. So you've got a max up here. Now it happens a lot. The max keeps happening, but that's your maximum. Oops, sorry. So you've got a max up here. So you got a max here. Let me zoom out a bit. You got a max here, you got a max here, you got a max here, you got another max over here. The max keeps happening, but that is your maximum value. It never deviates from that. This is your minimum value. And again, it happens lots of times, but that is the absolute minimum value. Your amplitude is going to be the distance that it goes between the horizontal axis up and the horizontal axis down. Now the horizontal axis is the axis of the curve. You got to pay attention to that. Sometimes it moves. Okay, so in this case it's not. It's at the theta axis. It's at the y equals 0 line, if you will. So the amplitude is going to be max minus min divided by 2, which is 1 unit. The period for is one complete wave cycle, one complete pattern or cycle, and that's going to be 360 degrees. It takes 360 degrees starting at 0 to get to 360 to go through that entire pattern. X-intercepts. Well, that's everywhere it's going to cross the x-axis. For this graph, it crossed here, 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 here. On one cycle, it's going to cross at 0, 0, 180, 0, and 360, 0. And that's on the domain 360 to 0, right? So if I'm just looking from here to here, then it's going to have x-intercepts here, here, and here. If I include more of the x-axis, there's going to be more x-intercepts. Y-intercepts. Well, it's only going to cross the y-axis at one point, and that's at 0, 0, right here. And it doesn't matter. I don't need a different domain for this. There is only one place it crosses the y-axis, which is right here, right? It crosses there. The domain, well, the domain for one cycle is 360 degrees. However, the domain keeps going. If we're thinking about this as a periodic function, it could keep going and going and going. The range, however, must have a minimum value of -1, and it must have a maximum value of 1. So every y value must be between those two. It can't go anywhere else. Okay, so we finished this nice little sheet. I'm going to stop there and see what's next.